All right, here we go. This is the chapter 2 test. All right, so how do I find relative frequency? Somebody tell me, how do I find relative frequency?
You take the frequency divided by the sum of all the frequencies.
Yeah, exactly. I take the amount of pieces of data I have. So 4, 8, 10, 6, 2, 2, and 1, and I get 31. That's my frequency. Okay, that's my total amount of things. And then I say, okay, well, each frequency is to divide by 31. You could give it to me as a percent. You could give it to me as a decimal. I really don't care. So 4 over 31 is going to give me 1.29. I'll do it as a decimal. 8 out of 31 gives me 0.258. 10 out of 31 gives me 0.323. 6 out of 31 gives me 0.194. And 2 gives me 0.065. And then 1 gives me 0.032. Right, so those are my relative frequencies. What should you get if you add up all of your relative frequencies? 1, right? So you can kind of spot check that and say, okay, I'm going to add up these relative frequencies. If I get like 1.5, you did something wrong. You punched something in wrong. All right, now cumulative frequency should be pretty easy. All you got to do is just keep adding up. It looks like I've got 4, add 8, add 10, add 6, add 2, add 1. Now, remember, your cumulative frequency, the last box in your cumulative frequency should be equivalent to your total number of entries. Questions about that? That was a huge issue on the test, on the quiz. I remember that being rough. So hopefully we understand that now. All right, let's take a look at number 2. Jump back here. Ooh, something in my eye. Ooh. I kind of cut it off there. That's okay. Use the frequency polygon. Come on. There we go. Okay, first thing that I want to do is approximately how many students took the first test. So that means I've really got to look at all my entries, right? I've got to look at all my frequencies. Looks like I have 0 students here, 5 students here, 10 here, 30 here, 40 with this, 15 here, and then 0 again. All right, so if I'm just going to add those up, looks like I got 100 students. Is that what you guys got? Yeah. 15, this is 70, so 85 plus 15 is 100 students took this. Which class has the smallest frequency? This one I kind of screen captured this off the book, and I didn't really think about the questions that we're going to go into it. There are actually 2 places that have this frequency of 0. That's the smallest frequency. So looks like, but now it's important to understand where the limits are. Okay, if I know this is 44.5, that's the midpoint, right? And I can see that it jumps from 44.5 to 54.5. That means the class width is 10. Right? The class width is 10, right? So what 2 values are going to give me the midpoint of 44.5? 40 to 49. Right? 40 to 49, because that's going to give me a midpoint of 44.5. The other class width here, I know it seems weird, but 100 to 109. 100 to 109. You might be thinking, wait. How can they score over 100? Well, what's my frequency there? Nobody scored over 100. Okay, both of those have the smallest frequency of 0. 50 to 59 has a frequency of 5, I guess, but that's still not the smallest. Which class has a cumulative frequency of about 45? What class is that? Somebody tell me. What class is that?
74.5.
The 74.5 class, right? So that means, because this is 5, 10 with the 30, that's 45. So 74.5, that means 70 to 79. Questions about that one? Cool. Let's take a look at number 3. Oh, no, I want the Word document, that's right. Okay, looks like I'm going to do a weighted mean. A weighted mean. Send to a new page. Just to kind of talk about it a little bit and to show you, please don't write on these because these are the copies that I want to use for the actual test. I want to show you the formula sheet that you'll be getting. And again, for anybody just watching the video, this is just a copy of the formula sheet that's already in your book. But again, please don't write on these because I don't want to have to make more copies. Okay. So it actually gives you the weighted mean formula. I mean, you probably didn't need it, but it gives you the weighted mean formula. Sum of XW over sum of W. Right? So the sum of XW, score is X, W is weight. So that means if I take XW's here, that's going to be, 75 times 0.05. That's as a decimal, 3.75. 90, it looks like I didn't do a lot of homework. I got a 75% of the homework. The quizzes, I've got 95 times 0.2, but it was only worth 5%. The quizzes, I got 19 points. 87 for my test average, so 87 times 0.25, which is going to give me 21.75 points toward my total. 90 times 0.2, 18. 92 times 0.3 gives me 27.6. Now, the formula says sum of the XW's divided by sum of the W's. What's my sum of my weights? Yeah, 1, or 100%, 1, right? So in this case, I don't need to sum those up. Like if I had, if I was doing like a 4-point, like a GPA scale, like a weighted GPA, then I would have to sum that up because it would probably be out of 4. But for our purposes here, we don't have to do that because we're getting out of 100, or 1 in this case. So I'm going to add all these up. It's going to be 3.75 plus 19 plus 21.75 plus 18 plus 27.6. 90.1. 90.1. Is that what you guys got? Check me, because again, this is the first time I'm doing this. You guys are my guinea pigs, so make sure that mine comes out similar to yours. And you can kind of ballpark it to make sure that it's going to come out the way you expect it to. The only thing pulling down my grade drastically is the homework grade, but that was, again, only 5%. And I did really well, 92 and 95 on the things that take 30 and 20, 50% of my grade. I got it above a 90%. So it makes sense that, my test grade is pulling it down below the mean, but not as drastically as the homework grade would be. So ballpark your answer. Make sure that it's what you expect it. Okay, now this is going to be fun. Oh, there. All right. Hours spent on homework per week of the students in a class are shown on. Oh, look at me. See, I change up the problem, but then I forget. That's not height. That's hours. Okay. Height was probably the original problem. Hours spent working on homework per week of the students in the class are shown in the frequency distribution. Find the frequency mean, variance, and standard deviation. You know what? You know what I'm actually going to do? I'm going to move this a little to the right, or to the left, excuse me. Send to the same page. Make this smaller here. Now, why am I doing this? Because I'm just going to add on to my table to find my other pieces. Because again, in the end, I'm going to need to do a lot of calculations with my frequency distribution for my variation and my standard deviation. All right, first thing I need to do to calculate my standard deviation and my variance, looking at the formula sheet here, I've got, and I said to use a population, right? So they have sample standard deviation of a frequency distribution. That's what we're working with here. They say sample. The only difference here is from sample to population. They don't even have the population. But you should know that population, I just don't do the n minus 1. I just do the n, right? Population in difference from sample, I'm just going to use n instead of n minus 1. But again, I believe I said to use a population instead of a sample. All right, so the first thing that I have to do is figure out, I guess, it's also got the frequency mean too. Mean of a frequency distribution. Sum of the xf's divided by n. Sum of the xf's divided by n. Okay. So that means to find my mean, I've got to find my xf's. X is my hours, f is my frequency, obviously. So xf is going to be 0, 7, 18, 15, 12, and 10. Right? That's my xf's. And if I sum up my xf's, that's 25, 40, 50, 62. Yep, 62. That's the sum of xf's. And then I've got to divide it by sum of the n, which is all of my frequency added together. So that's 9 plus 9 is 18. That gives me a 20. 28. Yeah. So my mean, my x bar in this case, or my mu, if it was population, is going to be 62 divided by 28, which is 2.21. That's what I used, 2.21. Again, if you round a little different, your answers may be a little different from mine, but it shouldn't be too far off. Okay, now it's really kind of up to you how you continue on with your table, because if I'm looking at the variance and the standard deviation, the formula for the variance and standard deviation is going to be sigma squared is going to be sum of the x minus x bar squared f, all divided by n, right? Okay. You're going to need to calculate x minus x bar squared. And you're going to need to multiply that by f. If you want to do it all in one calculation, that is completely fine. What do I mean by that? Like, take a look at my first row here. X minus x bar. 0 minus 2.21. 0 minus 2.21. I'm going to have to square that. And then I'm going to have to multiply that by my frequency, which is 2. This is like bare minimum to show. If you want to stretch it out with multiple columns, show the deviation squared, show the deviation squared multiplied by f in 3 separate columns, that's completely fine. But this is bare minimum here, 9.77. Okay, so if x is 1, I'm going to do that exact same thing. But now I've got 1 minus 2.21 squared times my frequency now is 7. 10.25. I'm going to round it to 10.25. Yeah. Okay, do the same thing, but instead of 1, my x is now 2, and instead of my frequency of 7, my frequency is now 9. 0.39, I'm going to round it to 0.40. Same thing. Now it's x is 3, and my frequency is 5. 3.12. Same thing. But my x is now 4, and my frequency is 3. 9.61. Was that 6.1? Yeah. And then lastly, 5 with a frequency of 2. 15.57. Okay, so that is, and again, it's very important to label what each column means. I give you tables that you could either extend or tables that you just need to fill in. So I'm going to add up all those x minus x bar squared times f. Got 9.77, 10.25, 0.4, 3.12, 9.61, and 15.57. 48.72. I had a see, I did my key wrong. I did this as 4 instead of 0.4. Okay, and now we take the sum of the deviation squared times frequency, that 48.72. We divide it by my n, which in this case, again, is the frequency, the 28. Not 27, but 28. So my sigma squared was 1.74. So sigma, and that's my variance. My standard deviation, my sigma, is the square root of that, which is 1.32. That's my standard deviation. Think about it logically. Go back and reason through, because at that point you can now decide, did I make an error in calculation? Like if you accidentally got that your standard deviation was like 7, that's way wrong, right? That is very wrong because your mean is 2.21. That means your standard deviation would go up to 9 and down to -5. No, that's way wrong. But if you get your mean as 2.21 and your standard deviation is 1.32, that means one standard deviation up is 3.5. Okay, yeah, that's good. One standard deviation below would be like 0.9. Okay, yeah, that's really good. Here is my one standard deviation away, which makes sense because look at my frequency. It's kind of tailing off on the upper side, isn't it? We would call that skewed right. Question about that. Again, we did a lot within that one problem, so you can see how I could stretch it out to be multiple problems. Take a look at the next one here. Number 5. 5, C. Oh, I did send to the current page. I don't want to send to the current page. It's going to get all jumbled up. That's okay. I can do this. I can fix this. There we go. Okay, consider the following data. Find the mean, median, and mode of the data. Give the 5-number summary. Draw a box and whisker plot. Construct a stem and leaf plot and a dot plot of the data. Find the population variance and standard deviation. So we're doing a lot with this data. A whole lot with this data. Let's take it piece by piece. Let's calculate the mean, median, and mode. All right, so the mean, I got to take the mean 10, 15, 18, 20. Okay, good. 22, 26, 28, 32, 34, 34, 38, 40. I think I got 317. 317, and I got to divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. By 12. I got 26.42. Yeah, we'll round it to 26.4. So the mean is 26.4. The median, okay, now I actually got to run that. It looks like I got boom, boom, huh, 27, right? The median is 27. The mode looks like I've doubled up on 34 out there. Questions about that one? Mean, median, mode. All right, 5-number summary. Okay, the 5-number summary would look like this. I got Q1. Actually, I got to start with min. Min, Q1, median, Q3. Remember, you jump Q2 because that's the median. And then the max. Okay, so the min is 10. The max is 40. The median we already found was 27. We just got to find Q1 and Q3. So I got to find the median. Now remember, the median was here, right? So that means I'm still going to use 26 and 28 to find my new first quartile. So here, right here, 19. 19. There's my Q1. And then I do the same thing for finding Q3. 34. There's my 5-number summary. 10, 19, 27, 34, and 40. All right, now remember that when you draw a box and whisker plot, you got to put it on a number line underneath it. So if my number line stretches from 10 to 40, I don't care how you do your scale. Like I'm going from 10 to 40 here. Let's go by 5s. 10, 15, 20, 25, 30, 35, 40. Sure. 10, 20, 30, 40. Now again, how I make these, I just draw lines at my 5 numbers. I've got 10, 19, 27, 34, and then right on the dot at 40. Draw a box around the middle and draw your whiskers. Again, if you had not had your 5-number summary directly next to it, you should label that. Put each exact number right above it. What do I mean by that? I mean just saying, okay, 10, 19, 27, 34, and 40. Let's make the stem and leaf plot now. Remember to put a key for the stem and leaf plot. Okay. Stem and leaf. Looks like I've got the stems of 10, 20, 30, 40. 1, 2, 3, 4. And looks like I've got a 0, a 5, and an 8 in my 10s. Looks like we had a 0, 2, 6, 8. 0, 2, 6, 8 in my 20s, and then a 2, 4, 4, 8. 2, 4, 4, 8, and then just a 40. Make sure people lost points for not putting the key, so just pick one, like 18. 1, 8 is 18. Again, I'm going to do for my dot plot, same type of thing. 10, 15, 20, 25, 30, 35, 40. And then just put dots on there. So 10, do it in a different color. 10, 15, 18, 20, 22, 26, 28. Oops, here. 32. Okay, good. 34, 34, 38, and 40. Now, the difficult part about this is going to be my population variance and standard deviation. Population variance and standard deviation. That's going to be the difficult part about this. Okay, I'm going to list it out. Actually, you know what? I'm going to screen cap this again onto a different slide. New slide. Okay. And then I'm going to make a table. Give me a table. Insert table. And I want it to be one more. I want 11 rows. And I'll do X's. I might not use all 5, but there. Oh no. I don't want that. Come on now. I just want to move it. 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 Oh, there it was. Oh. There we go. Stupid smart board. Ah, there we go. That's going to work. Okay, so if I want to find my variance and my standard deviation, the variance is going to be, I've got to do all those calculations. So let me start with, I've got 10, 15, 18, oops, that's 80, 18, 20, 22, 26, 28, 32, 34, oh shoot, 34, I mean, I guess I needed more, 38 and 40. Yeah, you get the idea. Okay, so there's our x's. The first thing I got to do is find the mean, but we found that already. The x bar in this case was 26.4. Okay. Now to find the variance, I'm just going to look at the population variance. Sum of the x minus mu squared, and that's mu again. This is population, so this is mu. Sum of the x minus mu squared, all divided by n. Sum of x minus mu squared divided by n. Now, again, you can separate it out in the table. You can show what x minus mu is. You can show what x minus mu squared is. That's fine. I'm just going to go straight to doing x minus mu squared. So I've got 10 minus, actually I should put this in parentheses, 10 minus 26.4 squared. 268.96. 268.96. Do the same thing with 15. $129.96. Same thing with 18. These should start to decrease as we go toward the mean. 70.56. Same thing. Oops. Same thing with a 20. 40.96. And again, this is x minus mu squared. Same thing here with the 22. 19.36. Getting smaller as we gradually get to the mean. 26.16. 28. gonna give me 2.56, 32, 31.36, 34. I have two of these. 57.76, 38, 134.56, and then my last one here, 40, 184.96. So I've got to sum all those up and then divide by n. Now, what is my n in this case? What is my n? Am I going to add up all my x's? No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is my n. So I'm dividing by 12. Not, don't mistake frequency distribution with something like this, where you're going to add up a column. No, I'm not going to do that in this case. I'm just going to add up my x minus b squareds. So I've got 268.96, 129.96, 70.56, 40.96, 19.36, 0.16, 2.56, 31.36, 57.76, 57.76, 134.56, 184.96. And then divide that by 12. 998.92. Divide by 12. And that's going to get me 83.24. And that's, combine my 2 and my 4. 83.24. Remember, that's the variance. And then, so if I wanted to find my standard deviation, square root that. Looks like it's about 9.12. Yeah. Standard deviation is 9.12. No. Look at it again. What's your mean? What's your standard deviation? Is it all falling relatively within there? All right. So this will be good. I got 3 problems, number 6, 7, and 8. I will do a video over this, and then you can watch that on Monday, and then use the rest of the period to work on your project. Remember, your project is due next Friday. Friday. If I can get the formula sheets, okay, thank you.
Put it in. Well, we're gonna get it back Monday anyways.
That's true.
It was a solid.
Okay, thank you.
Personally, I would come back. I'm gonna go make up that last one. The whole class. I've never had to make a lab for any class. I'm always asking questions.
That'd be kind of funny.
I asked her if she just wanted me to wait till science gets back and we get back together. And she said, no, I have to do all by myself.
Oh.
Yeah.
Are you gonna learn more time next week other than Monday?
I'm planning on Wednesday. Yeah. Right now, the plan is I was going to give you Wednesday on the project as well. Okay. So I'll give you Monday. We'll test Tuesday, and then I'll give you Wednesday for the project.
What are we doing Monday?
Hold on a second. Let me stop the video.
Monster review.